All right, good day, folks, or good night, depending where you are. I guess we're live. That's what it looks like. So, as I was saying in the comments here, nothing major for tonight. Just trying to figure out what I'm going to do next. I talked about some hydrogen experiments with RF a few videos ago. So, this is basically the setup, a few things, nothing running yet here. This is resistive and basic voltmeter and a motor here and an amp meter. So that's what I've been using a lot. I'm sure you've seen it a few videos. And so this is what I'm working on. This is a tank. And the whole idea is to put some salt water in here. And I've made a coil wrapping for whatever it's worth. Not sure if this is going to work yet, but to try and feed it with RF. Now, according to the original plans, it needs to be around 13 megahertz, but there's so little actual experiments done in this. I don't really know if that's really a rule or not. So I don't have a 13 megahertz transmitter right now. But what I do have, there's a few methods, and I'm not sure yet. I'm actually thinking out loud. Do I build a flat coil here and drive it like a Tesla coil? And I got these gas discharge tubes to imitate the spark gap and just see if random RF energy will do it. Or do I choose a more balanced approach? Traditional RF transmitters. Now I got this thing here, which I think is what I'm going to do. It's a 1 watt USB FM transmitter. It's got an SMA output. So I don't know if 1 watt is enough to drive it, and I don't know if 100 megahertz, basically, which is the FM broadcast band, will do anything to the water like make hydrogen. So I guess sometimes this is part of the experiments to figure out what works and what doesn't. And at the same time, trying to not make a fool of myself here live, not knowing, what the best course of action here is. So I'm ready for a few possibilities here. I made sure these are all well sanded off, so I've got a good contacts. So this is a regular electrolyzer over here. I filled it up with water. It's nothing going on. Something else I was thinking, the one wire back EMF. So a few things I got going here while I want to get ready anyways. And high voltage generator here. Got a battery on one side. So the scope is over here. Sorry if I don't talk all the time. This is part of being live. I'm trying to figure out what to do here. So maybe if I want to drive it with the FM transmitter, 1 watt, I don't think it's going to work, but you got to start somewhere, right? So I've got too much here and I'm getting confused as to which way to go here. So the first thing would be, I guess I need to find an adapter, right? SMA. Oh, there's one right here. BNC to SMA. Wow, that's really seized in there. Lovely. Come on. There we go. So that's a start. So now I get BNC. Is this male to female? SMA. So it's female on the transmitter and male. Okay. I hope I didn't say anything wrong with the male and female, by the way. Bad joke, I know. It's just, oof, these days, connectors apparently need to find a new name for them to keep everybody happy, I think. Let's see now. So now we need a coax, right? So I could use, right here. So this could be the B and C output, like that. And then all I did is this would clamp on to here. Now we're dealing with RF and especially really high frequency, and I don't want to blow this up. So what I'm thinking here is let's run it like a high Q coil as an RF, but basically the whole thing is a coil. And let's terminate it properly. This is a 50 ohm transmitter. 50 ohms, so that's important. 50 ohm cable here. So I guess I better look for a 50 ohm resistor, right? Or something close to it. So resistors are all labeled here. I'm looking for 20 to 75 ohms right here. 20 to 75 ohms. What's this here? 75 ohms. $75 ohms. Just 100. It's too much. We're all labeled once upon a time. 75 ohms. Just don't feel like here, because I knew I had them once. 100 ohms, lots of 100 ohms. 100, 100. Sorry for the mumbling, I'm just trying to find here something close to 50 ohms. I might use that 75 because it's better than nothing. And then I have to find an hour for my values. Or take the meter. Alright, so 75 ohms for now, close enough. I've got a load, so it's not like it's an open short. So I guess we're going to close the loop in RF terms, or an antenna, because this is a bit of a different system here. Don't even know if it's going to work, so you got to try more traditionally. Slowly build yourself up. If we notice something works. So what I'm doing now is I'm putting the 75 ohm resistor on one end here. And that's going to be basically imitating a load on there. At pretty close to what the transmitter is expecting, so we're not going to get a massive SWR reflected power here. which would be great, by the way, if we're trying to create scalar waves, which could be something to try. Don't know if scalar waves would actually enhance the effect, but don't want to blow up my transmitter, so can't use that. So again, folks, if there's anybody watching, I can't really tell from here. I'm sorry if I can't interact. The computer's right over there and I'm over here. But I'll do my best. I think YouTube saves this afterwards and you can see all the comments, and I think you can comment afterwards. Again, this is the first time I'm doing the live thing. I'm testing it out at the same time. We'll see how it goes. Pretty spontaneous. So this is supposed to go on your computer, but what I'm going to do is I'm thinking of this little capacitive power supply here. I know some people scrutinize me because they go, that's not capacitive, it's not reactive, it's switching. Well, yeah, of course, the switching circuit is inside, but it's still a capacitive input. But reactive power is very minimal. So, you get an amp or less, but the point is, for this size, what do you expect, right? It's not like we're running capacitors on every device in the house, even though technically you could if you find the right values, right? But I guess that's another video for another time. I've covered it, if you're wondering, reactive power supplies. So this is essentially a way that the manufacturers are doing it more and more these days. And you can't blame them. It's pretty efficient. And it's enough to drive a tiny little switching power supply built into here, which drives the 5-volt USB port. So I'm thinking, connect this in here. And now I need an extension cord. But I guess I better figure out something here. I gotta fill this salt water, right? Salt water. I'm gonna have to mix it. I'm just thirsty here. I'm gonna have some Diet Pepsi. Okay. Extension cord is right here. I'm gonna plug one end anyways. Again, no clue when no clue. This is probably not gonna work. But like I said, it's a start, and save somebody else all the hassle of doing the very same thing. And science one way or another. All right, so now let's mix my salt water. Salt water, that's in the kitchen. Here's my salt. I don't know how much we need, but we'll put about 15% of the cup. They say it works with seawater, so I don't think there's more salt than water in the sea, right? So this should be okay. Just set the hot water. Coming fast. Come on. It's like they shut the water off at night. It's only lukewarm. It's gonna have to do. All right. So lukewarm water is what we get. Don't know why, but what time is it? Oh, it's past 12. Maybe that's why. Just gonna mix my salt water. this is probably not going to work. Not to discourage anyone here, but frequency is completely off. Don't even know what power we need. I'm assuming this is probably a high current thing, like 50 watts. I only have one, unless we do the one wire thing, which is, again, I'm not there yet. Use the high frequency oscillator, trigger it at 1%. And some people recommended actually putting some rods right in the, like drive the electrolyzer itself with RF, but wouldn't that eat up away into the metals into the electrolyzer? I wouldn't want to ruin my thing, you know? Lots of questions. Okay, so now a funnel of sorts. That I had, but now find me. And I think I just got something like that today, actually, at the store. Or find somewhere in here. Just looking for something that I can put the liquid in there. I had a funnel and fun, I can't find it. Use this. Yep. So there's a pipe there because it's huge. This wasn't designed for that. So I'm gonna put this pipe here. Lift it up to make sure that it doesn't put a tape on there. For now. And all right, so I'm gonna put the salt water in there. Give it another. That's all disintegrated, so that's good. So I have no clue what the outcome is, and it's late, so just trying something out spontaneously here. 1 watt FM transmitter at 100 megahertz with a coil around here in the plastic. So I'm just filling it up. So there's nothing inside here but the water, the coil's on the outside. So a bit unique way of trying to get the hydrogen. But again, I think the frequency may matter or it may not, but I think it does. I actually wish there'd be more information about this. The guy just said he did it at 13 megahertz. Few have replicated it on YouTube. With ISM equipment, I believe. Which means it might be, wait a minute, ISM band. See, that's a 1 watt limit, I believe. So maybe that's all you need. It just occurred to me now. Maybe I'm wrong there, but I think the ISM bands, the ERP, the maximum is 1 watt. I'll have to check that out, but I think so. So this is not any higher there. There's enough water. Okay, there's more than enough. Put this over here. And I'm going to take this pipe off. This is a fuel cell hydrogen. It's just a single cell. I have many more of these. I can go up to about 12 volts if I had the gas. But for now, just to monitor to see if anything at all is happening. If we can't drive one, we most certainly can't drive 10 of these, right? So let's plug this in here. So the gas would push up, go out here. This is where this little box here comes in handy. We're able to see if there's any voltage at all. This is on open now, so there's no load. And if there is a voltage, if we can run a little motor and a basic current meter, which gives us an idea of what's coming back. All right, so obviously that's reading 0 because we're not doing anything. So this would go back in there and it would push. See, usually the gas accumulates and pushes the water up. So I don't know how that's going to work, because usually it's the electrolyzer that connects down there and feeds it. So this is, anyways, we'll try it. We'll quickly find out if it works. All right. So what would happen is water would also start. That's if I would block it from here. But we don't want to do that. This is not a pressurized system is what I'm trying to get at. So here's our RF transmitter, 1 watt, 100 megahertz. We're plugged in through the coil. We've got our 75 ohm resistor because I was lazy. I couldn't find 50. So for the sake of the experiment, I guess I'm going to plug in the extension cord now and turn this on. And I guess the thing is to just wait and see. I didn't think I'd get it this far tonight. I was just pondering, figure out what the first experiment would be. But again, ideally, I'd want you would want to at least try it the way it was shown on YouTube, right? With the proper ISM equipment at 13 megahertz. It looks like he had more of a waveguide system. I had the idea of doing the coil around. Will it work? Still a lot of questions. A lot of people in the comments always ask me, will this work? Will that work? Well, a lot of it I got to try before I could even answer. So, and sometimes I'll say like Bedini, right? You have an idea in your mind and it works in your mind, but doesn't mean it's going to work in real life. So, all right. So what am I looking for is a power plug down here. Actually, I'll plug it on the other side just because a lot here. Don't want to knock anything out. Here. Yeah, that transmitter talks. All right, so now it's running and it's going through that coil. And if there'd be anything at all, the gas would be going through the cell and out, and I'd be reading something here. How long is this supposed to wait? I don't know. Is this even going to work? Guess we could listen to the feel of the radio here. Yeah, see, it's a dead carrier. The field is pretty contained, which is good. So the resistor or the coils, see, that's pretty. I'm just seeing the dB level as I get closer to the coil here, 58, 59. It's radiating. Will it be the right frequency, the right power? I don't know. So I'm not sure what I'm looking for. Bubbles. I don't think this is going to work this way. It needs more something tuning. Transmitter's not running hot, so that's good. There's a little resistor here. That's okay too. So what I could do is I could block it with my finger here real quick to see if it gathers up on here, but it doesn't look like it is. So this is what I wanted to try, folks, is to see if other frequencies, maybe at low power, would trigger it better than 13 megahertz, meaning higher frequency, closer, even though it's still a long way from microwaves. At 100 megahertz, it's still a lot higher frequency than 13. But again, it's right in the broadcast band, so that could potentially be an issue. But if it's well contained, like we're doing it through a load and everything, it only travels a few feet, so. So I'm not seeing any accumulation yet or water being pushed up. Let it go. Still 0.00. So again, if this would work or be efficient, we'd have some sort of something by now. I've done this before with the electrolyzer, and within seconds there's bubbling. So yeah, I can't do anything with this, even if it's happening on a microscopic level. Not seeing it, and I'm definitely not going to try putting a match near it either. But visually, there's nothing going on. My meters, I don't know if you can see them, are showing a 0, 0, and I've got it open, so no load or anything. And it's not flickering or anything. And we're driving this at 1 watt at 100 megahertz right through the coil with an FM transmitter. Something I wanted to try real quick to see if this thing was, frequency picky or not. And my idea was maybe at higher frequency, you need a lot less power to trigger it. But again, I had a feeling this was probably not going to work. But I wanted to try the live thing and to show you the progress with the idea of the coil. There's many more things to try here. I could run it, like I said, like a Tesla coil, put a primary here, and try and drive it like that and see what happens. Or, of course, find the real ISM band 13 megahertz transmitter and take it from there. That'd be a good idea, but there could be a cost associated with that. It's December, so that might not be right away, unfortunately. I could probably build something crude, but I don't like that. That's a lot of interference at 13 megahertz. But what I do have an idea is maybe it works on the audio frequencies. What if you take a 1000 watt amp? Yeah, that'd be a waste. Maybe a 25 watt amp, audio amp, modulated with if certain tones, certain frequency sweeps. See if that does it. Because you do get a feel with an audio. It's a type of AC, just a different part of the spectrum. But maybe that's too low in frequency. So here I am talking, and they're still at 0.00. This is definitely not doing it. All right, so that's all it was, a little 1 watt FM transmitter. I used to have a CB radio, 27 megahertz. 4 watts, I guess. Could have tried to drive it with that. I was doing something. It's a little warm, not very hot there, but I can tell on the resistor. The resistor was at least not. What I'm trying to get at is most of the radiation was being efficiently thrown out the coil, because if not, the resistor would be really, really hot. This was just a little resistor. Well, it doesn't, because this is only 1 watt, so even if it's a half a watt, they have a problem if half a watt is actually being. Anyways, here I am rambling. So now, back to the original idea. We run it as a Tesla coil. The secondary is already built. So is it a flat primary or as a cone, or do I do it layered on top of the other? Something I think tonight I'm not going to do, but I can ponder about it. And this one here now. Yeah, I was going to try and drive that with back EMF. That's right. Sometimes I forget what I was going to do. So I did that before in another movie, but I think I never did it with the, it was the really high frequency oscillator here I used for the one wire system. I wanted to see if I get more efficiency with that. So as you can see, this is how I basically work 1 or 2 things on the go here that are related. And one thing basically leads to another. I make a conclusion, and then I ponder about it. And then I move on to the next thing, what I could do and what I got. But yeah, I was not that excited that anything was going to happen with this tonight. But so the next step, folks, would be what would be the next step? Tesla coil here, back EMF there. One thing I do know is my mouth is so dry. Winter time. Oh. It's so rough in northern Ontario. I know, I've got the tablet. Let's ask ChatGPT what to do next. No, I'm just kidding. They'll tell me to find a certified electrician. That is very dangerous to use a USB charger without supervision. I'm not joking, that's what it does now. Used to be good. And if you argue with it, well, they tell you you're breaking community standards. So don't argue with it when it tells you to find a certified electrician because it knows best and it's very concerned apparently with our safety. So, you know, that's community, whatever they call it, community standards. That's it. I didn't think a bot could get its feelings hurt, but apparently this one does. All right, so I guess we're gonna wrap it up for tonight, folks. It's already, oh my goodness, 12:30. The neighbors are gonna wonder what's he doing talking to himself. It's also like the weekend, but we've got also a lot of old people that live here, so these are apartments. So before someone does something stupid here and gets all huffy and puffy, we're gonna wrap it up for tonight. And thank you for bearing with me here and just testing the live feature for the first time. Pretty nifty. I hope it works out, and hopefully it's gonna add this in my playlist of regular videos because if it keeps it as a live event, I mean, literally no one's gonna find it. And of course, if you had any comments, I'm going to eventually find them as I get there when I pause my video, and hopefully it's going to process it properly. And a good sign, hey, there was no ball lightning while we sat here. So, hey, there's a start for everything, right? That's half a joke. But anyways, thank you all for watching, and we'll see you. And I'm just going to head over here and see if I can turn this off without blowing anything up here, folks. Thank you, and have yourselves all a great day or night, whatever it may be.